Hey everybody, this is Larry. This is me doing day 25 of the June Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. And of course, you can see I'm still in Lisbon, just having fun, time of my life. Yeah, follow that IG for detail, I guess. Today's poem is 1575, Count All Possible Routes. Okay, seems like it'll be DP. Oh, I mean, the now whenever you see a combinatorial E problem, it's probably gonna be DP. It's either that or a formula, right? And you have to like figure out the formula. But first of all, let's do the mod thing and make sure we don't forget about mod. Okay, so now we have I and J. Oh, okay. Yeah, the first thing I wanted to look at was just n, right? If n is 100, then we can go pretty far with being expensive with the complexity. So let's take a look. Okay, what is the problem? Okay, locations of I. We're starting at start, finish, view. Okay. Are these sorted? No, they're not sorted. That's kind of awkward, but do we sort or? You are allowed to visit any city more than once. Okay, well, in this case, view is 200, right? So that means that basically the way I think about these is just brute force in a slightly smarter way, which is with memorization. Once you do brute force, that should be pretty straightforward to implement. And the brute force here is just based on the state of the view and the current location, right? Because current location can have up to 100 points or 100 different inputs, and view can only go up to 200. So you have 100 times 200 times 100 or something like this for a brute force, and we should be good. So let's get started. I think that should be good enough for us to start. We can do something like count from start with the amount view, right? And then here we have the current location and the current amount view. If view is less than 0, maybe even add 0. Okay. If view is less than 0, we return 0. Otherwise, if current is equal to finish, we return 1, right? And then other than that, yeah, and then you just brute force doing every possible one. So then that's basically continuing the path to index I, and view minus the cost, right? The cost is going to be absolute value of locations of I minus locations of start, right? And if view is, I guess we don't need that if statement because of the other if statement, but the other thing that we want to do is we want to make sure that there's no infinite loop. So you want to make sure that I is not equal to start. Are they all distinct? They are distinct. Okay. Or I is equal to start, we continue. And then total is going to, and then we sum up these totals, and that should be good. I mean, of course, we have to do some mod things, but yeah. Well, that's unfortunate. Oh, I see. Because we terminate early. That should still. Is it exactly 5? No, that doesn't matter. Well, we are terminating early, so this is probably going to be incorrect. We'll do something like this. Really, to be honest. Maybe that's why, but returning 1, returning 20. So wow, we're kind of off by a number of ways. Oh, it's not if I is equal to start, it's if I is equal to current. Whoops. I mean, we fixed the situation, and this is current as well. Silly mistakes here. Oh, and that fixes it apparently. So yeah, here we have to do some memorization. As we said, current can go from 0 to n, view can go from 0 to 200, which is an arbitrary constraint. So maybe you could say it's f. And so yeah, let's add the cache as we always do. Times 4, right? And let's actually memorize it by using the cache. Oh, no, that's right. But I think that's the core part of it, is that the way that we think about this problem is just that it is brute force, right? Except for that we are brute forcing in a way such that we're reusing certain components and a way that represents what we call states in a way that is representative of the subproblems, right? And what I mean by that is that that the states, these are things that describe the situation or the scenario, the subproblem in a way that is unique, no matter what, right? So, and here, if you have the current location and the view, it doesn't matter how you get there. It's memoryless, and that's basically the components that are needed for dynamic programming. Yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.